Okay, if you use a calculator to work all of these out, I know you can't work out 64, but just put that one to one side, work out the others, and then see if you can find the odd one out. Pause the video now while you do that, and then when you're ready to proceed and talk about the odd one out, unpause the video. So hopefully you worked them all out and you got all of them except one to be 64. And the one you didn't get to be 64 was 2 to the 3 times 2 to the 2. And there's a reason for that, which we will establish and we will revisit this starter once we have established that. But it is to do with the powers, and it's to do with the number of 2's we've got and how they're interacting with each other. So we're going to talk about numbers raised to powers or raised to an index, and we're going to establish a few rules and terminology and then practice a few questions. So when something is written in index form, it's made up of two components, a base number and an index. So the base number is the 7. Think about base, the bottom of something, it's the number that's lower down, and then the index is also called the power. And there are a number of rules which we follow when working with these. And we've got the rules to speed things up, to make the calculations a bit quicker when we can generalize things and apply these rules. So the first rule is you can't combine things that have different bases. For instance, if you got 2 times 2 times 2 times 2, we could work that out to be 16, but if we're thinking about index form, we'd say that's 2 to the power of 4, because we've got 4 2's. And it's a shorter way of writing 2 times 2 times 2 times 2. If we had 3 times 3 times 3 times 3 times 6 times 6, we would have to simplify that to 3 to the power of 4 times 6 to the power of 2, because we cannot combine things that have different base numbers. We have to keep the 3's and the 6's separate from each other. You might think, well, 3 times 6 is 18. Isn't it 18 to the power of something? No, it wouldn't work out to be the same. And it's because of BIDMAS and the fact that indices happen before multiplication, which would mean if you wanted to get that 18, you would have to work out all the powers first, and it wouldn't end up being 3 times 6, so you wouldn't get 18. If we look at another one, we've got 4 times 4 times 5 times 5 times 4 times 5 times 4. Now, it doesn't matter if they're all muddled up, because you can reorder a multiplication and it'll give you the same result. So you just got to go through and see how many 4's you've got, how many 5's you've got. So we've got 4 4's, making it 4 to the power of 4. And we've got 3 5's, making it 5 to the power of 3. And we cannot combine the 4 and the 5 when working in index form. And then it works beyond numbers. It works with algebra as well. So if we've got n times n times n times n times n, that is just going to be n to the power of 5, because we've got 5 of them. All the previous ones you could work out to be an actual number. This one you have to leave as algebra, because we don't know what the value of n is. So that's rule 1. Let's have a look at rule number 2. So rule number 2 is about multiplying numbers in index form. So let's have a look at a question. We'll work it out the long way. We'll establish a rule, and then we'll look at how the short way of working it out is. So if we've got 3 to the power of 4 times 3 squared, well, 3 to the power of 4, that's 4 3's, and 3 squared, that's 2 3's. So altogether we've got 6 3's. So that makes 6 3s. We would write as 3 to the power 6. But there was a quicker way of doing that, which we'll look at in a moment. Let's do one more example. So we've got 7 to the power 3 times 7 to the power 5. If we write that out the long way, you're going to realize hopefully you've got 8 lots of 7s multiplied by each other, making it 7 to the power of 8. So what do you notice? Hopefully what you notice is, because you had 3 to the power 4 and 3 to the power 2, 4 and 2 makes 6. Obviously it's going to be 3 to the power 6. 7 cubed, that's 3 7s. 7 to the 5 is 5. It's going to be 8 7s, obviously, because 3 plus 5 is 8. And that's what we can do. We can add the powers to get our answer quicker than writing it all out. I've got a summary slide at the end of this, which puts these rules in a much more concise fashion. So I would listen for now and make notes from that summary slide later on. So another rule is dividing numbers in index form. So let's have a look at an example. You've got 4 to the power of 5 divided by 4 squared. Now divide you could write as a fraction. You could write it as the top row of the fraction is 4 times 4 times 4 times 4 times 4, and the bottom row of the fraction is 4 times 4. And then you can cancel things out top and bottom. So you can cancel things out top and bottom as far as there is to cancel out with what's on the bottom. So if you cancel out 2 top and 2 on the bottom, you're left with 3 on the top. 4 times 4 times 4, that's 4 cubed. So look at another example. 5 to the 6 divided by 5 to the 4. Let's do the same thing. So we've got 5 times 5 times 5, 6 times on the top, and times 4 times on the bottom. And if we cancel out top and bottom as far as we can, so crossing out 4 5s on the top and 4 5s on the bottom, what we're left with is just 2 5s on the top. 5 times 5, that's 5 squared. What do we notice now? Hopefully you notice, because I'm cancelling out ones from the top and the bottom, the quick way of getting from this question to the answer is subtracting the powers. 5 take away 2 makes 3. So 4 to the power of 5 divided by 4 to the power of 2 makes 4 to the power of 3. So in general, two numbers divided, same base, subtract the indices. 5 take away 2 makes 3. 6 take away 4 makes 2. And remember, I've got a nice summary slide to show this. Okay, you can combine rules. So we've got 2 rules. When you multiply numbers in index forms, you add the powers. And when you divide numbers in index form, you subtract the powers. So you can combine the rules. Just got to work following BIDMAS order, which is in this case left to right. So 8, 8 and 8 are my base numbers. So I'm not breaking rule 1. I can combine all these. And I've just got to do it step by step. So 8 to the 7 times 8 to the 5, add the powers. It's going to make 8 to the 12. 8 to the 12 divided by 8 to the 3, subtract the powers. So I've got 8 to the power 9. It's really tempting there to divide the powers because you see a divide sign. And 12 divided by 3 makes 4, but it's not, it's subtract. Okay, let's look at the next rule. So the next rule is a nice easy one. It's the power of 1. Now if you work these out on your calculator, 6 to the power 1 should get 6. 4.7 to the power 1 Well, 47 to the power 1, you should get 47. You should get all of those giving you the same number, just without the power of 1 anymore. So when you've got power of 1, we don't need to write it. It seems like it's an easy rule, but it's more useful the other way around, because some people can ask you to do questions that involve the power of 1, but they won't write in the power of 1. So you've got to realize that it's there. So for instance, you might have 6 squared times 6. And you might want to add the powers, and you see a 2, and you don't see anything else, so you think the answer is 6 to the power 2. But actually what you had was 6 squared, 6 to the power 2, times 6 to the power 1, and you should have added them to get 6 to the power 3. So it's useful to know for that reason. Okay, then let's have a look at the power of 0. Now this is slightly counterintuitive, but let's look at an example and realize why it's true. So if you got 6 to the power 4 divided by 6 to the power 4, well, it's going to be 1. Anything divided by itself makes 1. But let's also use the rule where we've got to subtract the powers. So that's going to get us 6 to the power 0. That means that 6 to the power 0 is 1. It seems confusing. It seems like anything to the power 0 should be 0, but it's not. Anything to the power 0 is 1. And it's because of that second index law. And it's also because powers are repeated multiplication. When you start with multiplication, you start with 1 times something. That's what all your times tables start with. So the starting point for multiplication is 1. So if I don't do any multiplication, I'm still at 1. The reason it's confusing is because normally when you multiply anything by 0, you get 0. And that's because multiplication is repeated addition. And you start off at 0 and add and add and add. And if you don't do any adding, then you stay at 0. But with multiplication, with raising to a power of 0, you end up with 1. So some straightforward answers, questions and answers. 10 to the power 0 is 1. 3.452 to the power 0 is 1. 723,538,592 to the power 0 is 1. They're all just equal to 1. And it's easy to remember right now, but it's whether you remember it in a week or a month's time. Just don't put the answer is 0. This is just one of those rules you've got to have memorized. Okay, one last rule we're going to look at. Raising power to a power. So let me show you what I mean. You might have 4 cubed all squared. Now squared means multiply by itself. So I could write that as 4 cubed times 4 cubed. And then I can use index law number 2 and I can add the powers and I get 4 to the power 6. Is there a quick way though? Can I get from the question to the answer in a quick way? And the answer is yes. I've just got to multiply the powers. If I multiply those powers, 3 times 2, I get 6. Okay, so I've been promising it for a while. Here is your summary slide. So I've got all the index laws and I've got little annotations as well. So I've got the first one, which basically says when you're multiplying things in index form, add the powers. The next one, when you're dividing things in index form, subtract the powers. When you're raising a power to a power, or you've got brackets and powers, you multiply the powers. And then you've got your other 2 rules where something to the power of 1 is just equal to something. You don't need to write the 1. and anything to the power of 0, apart from 0, is equal to 1, because it's repeated multiplication. I'm starting at 1 and I'm not doing anything. I'm not multiplying at all, so I'm still at 1. And there's a reminder of your base number in your index. Right, I suggest you pause the video now and have a go at making some notes from this. Copying out the slide I think would be a good idea. And then once you've unpaused it, we'll have a go at a few questions. Okay, so if we have a look at this question here, we've got 48 to the power of 9 brackets to the power of something, and the answer is 48 to the power of 18. And I want to know, what is that missing number? Okay, hopefully you worked it out. Hopefully you worked out that it is 2, because 48 to the power of 9 all squared makes 18, makes 48 to 18 because it's 9 times 2. Okay, right, my interactive slide is not being quite as interactive as I would like. Which means that I can't move it on to the next question. So what I'll do is I'll put a few questions on an assignment for you to have a go at, and that way you can practice these. Okay, so hopefully that's everything you need to know about index laws. If you need to know something more, just ask.